All right, phase. When we're going to talk about sort of audio in like a theoretical way, we usually do a sine wave. If I just draw that out. Now, sound doesn't really look like that in reality. It looks just like white noise almost, just kind of random bits and pieces. But when we're talking about it, you know, in a scientific way, this is kind of the best way to represent it. And you'll see it on an axis going 0 to 360. That basically just means it's like a cycle. The way you plot these graphs is with like a little circle. In a perfect world, a sine wave is going to cross 90 at its most positive part of the wave, and it's going to hit 270 at its most negative part of the wave. In reality, that's rarely ever going to happen. Sine waves have got their own stories. They're much like humans. They kind of, you know, they all do different stuff. So another example of a sine wave will probably sound exactly the same. Is that one. Now they've got the same information minus that stupid curve I've just drawn. But we can see at this point that when this bottom curve's at 90, it's obviously got a negative value. And let's just call this, you know, -1, +1. -1, +1. All right, thinking about maths, 1 minus 1 equals 0. So what can we say about these two waves and what they might do to each other?
Cancel each other out.
Yeah, so the resultant of these two waves on top of each other is silence. And that is kind of what's known as being out of phase. All right, so some scenarios where phase crops up in studios. We've got, you know, anything that's got two microphones. Those two microphones are not going to receive exactly the same part of the wave. One microphone might see the wave at that point, another microphone might see it there. And we can see that they're not the same values or positions in that sine wave. Put them to the side. And let's just think about more of a studio application. So we'll do the simplest kind of example, which is a drum kit. I'll just draw it as a nice box for now. Drums. Okay, let's imagine we've got some room mics on this drum kit, and we've got room mic B. And we've got room mic A. We imagine the sine waves just begin at the very start of the drum kit. Let's just take them like that. That's now reaching B at that point in the wave. If I try and copy that exactly, they're about the same, aren't they? Those two waves are going to do an element of adding together, making more volume than each individual wave adding together. And that's because if we just think of this as being our center point, or even this being our starting point, to be fair, distance from there to there is the same as that to that pretty much. You know, they kind of kept the same distance from the source, so the sine waves emitting from the source are going to do the same amount of rotations before hitting each mic. We put room mic A over here instead. Suddenly we've kind of messed with that. If I do another sine wave to that, you know, I could be in any phase of the wave over here, which is then going to cause me to be a little bit out of phase. That's because this A and B are less likely to receive the same part of the wave as this A and B. So to keep things in phase, we measure equally from one part in the room or one part in the venue or whatever. With we're checking phase, or we're using the polarity switch on a console. So let's just imagine we're bringing both of those tracks in. So we'll call this channel A, channel B. We'll put our gains to about 3 o'clock. Some faders at the bottom. Every single piece of audio equipment is probably going to have a polarity switch. I've just drawn it wrong. And it's usually going to live somewhere around the gain pot. Let's just imagine that this is what the waves look like as they're reaching the console. They're in phase, yeah, they're going to add together. They're both in the same cycle of that wave. Let's just say we press this polarity button down. That's then going to make the B wave look like that. If I do that, add that, I'm going to get 0. So the polarity buttons in the console are just a way of checking that we have got things in phase. Sometimes it'll sound better, sometimes it will clearly indicate we're out of phase with the two sources. It's just a functional way of checking that phase without having to move the microphones, around so much. So, phase in summary. Mics, same distance from source. That's going to be your best way of getting 2 mics or 2 sort of capturing things in phase with each other. We can then check that using a polarity button, which is basically just flipping the sine wave within the console. And that's going to tell us whether we're in phase or out of phase or nearer in phase. And that's it.